So I recently reworked my digital to synchro converter so that instead of 3 boards, it's down to just this 1 board. I also acquired this static air temperature gauge, which is probably the simplest aircraft instrument I've seen. It's nothing more than a synchro receiver connected to the needle that you see on the front of it there. So if I use the digital to synchro converter to turn that synchro receiver to different angles, the needle will move in step with the angle. To control the angle, I'm using my USB knob box I built a few years ago. It's plugged into a Raspberry Pi 400. It just determines what angle that encoder's been turned to, and then it sends the angle to this Raspberry Pi Pico on my digital to synchro converter board. That's hooked up to the scope that you see in the background, and then the output of the digital synchro converter is also connected to the synchro receiver inside the static air temperature gauge. So right now it's at 0 degrees, and I have some little buttons here that I set up for different angles. That's 90 degrees, that's 180 degrees, and that's 270 degrees. And I go back to 0 degrees, and I can do some fine adjustments using the large encoder on the large knob on the encoder board. And as you see, the waveforms change, the position of the needle changes too. So 0, 90, 180, 270, and I think I also programmed in 120 and 300 just because I kind of like the transition on the scope. So right there, the blue trace is in phase with the power supply, which is the yellow trace, and then when I change it, it'll the green angle will go through one complete or half a complete cycle, and then the blue angle will be out of phase. So let's change it here. Anyway, this is by far the simplest aircraft instrument I've seen because it's basically just the synchro receiver, needle, and then a little red light that you can kind of see a little bit of there. Thanks for watching. Bye.